Hello dear viewers, welcome to another video tutorial of this YouTube channel. In today's tutorial, we're going to be focusing on question number 6 coming from the 2024 Internal ECZ examination for school certificate ordinary level additional mathematics paper 1. And the question that we're going to be interested in today's tutorial, it is question number 6, which falls under the topic of trig identities. So let's try to check where the question is located in this paper. So it is question number 6. So let's try to check the location. Let's try to check where question number 6 is located. Okay, so that is question number 6. This is the question that we are interested in today's tutorial. So as we earlier said, this question falls under trig identities. It falls under trigonometric identities. So this is the question. So the question itself, it states that prove the identity. So that is what they want us to prove. It is cot x plus tan x is equivalent to sec x cosec x. And that question, it is carrying 4 marks. So we're going to prove that in this video tutorial. So we're going to see if cot x plus tan x is going to be equivalent to sec x cosec x. So before I get into the solving, I hope you haven't forgotten to subscribe, to like, to share, and to comment. So please subscribe so that you're always updated with each and every video tutorial which is uploaded on this YouTube channel, and also share so that others can also enjoy the tutorials of additional mathematics. And also don't forget to comment so that we can hear out your views. And last not the least, you can like this video by giving it a thumbs up. So now let's quickly go into the solving. So this is the identity that they want us to prove. So what we're going to do is that you can select any part which you want to, which you think that it can be easier for you to prove. So now, according to this video tutorial, we chose the left hand side. So we're going to solve what is on the left hand side so that it gives us sec x cosec x. So now, one thing that I can advise you is that when you want to prove identities, first check. You need to check and look at what you have, and you need to identify which part can be easier for you to prove. So if you want, you can choose the left hand side, or if you want, you can select the right hand side. But according to this video tutorial, we chose the left hand side. And another advice that I can offer is that you can take terms to cos x and sin x, because that way it is going to be easier for you. So in such a case, we have cot x. What are we going to do? We're going to simplify this one. It will be, so cot x is equal to cos x over sin x. That's one thing that you need to keep in mind. So cot x is equivalent to cos x over sin x. And then what about tan x? Tan x is equivalent to sin x over cos x. So the next thing that we so as you can see, we have converted the terms to cos x and sin x. So what is the next thing that we're going to do? We're going to solve this one. So since we have fractions, so that is the additional fractions. So what we're going to do is that we're going to find the common denominator, and the way we find the common denominator is that you have to multiply the denominators on both fractions. So in such a case, the denominators we have sin x and cos x, so we're going to multiply those. So it will be sin x cos x. And then what is the next thing? We're going to take the first fraction and divide. We're going to divide the common denominator by the denominator of the first fraction. So when you divide, what you're going to remain with is cos x. So it will be cos x, and then you have to multiply that cos x by the numerator. So that's what we're going to do. And then we're going to maintain the plus. We're going to maintain the plus like that. And then let's go to the next thing. Again, we have to divide the common denominator by the denominator of the fraction which you are given. So in sine x, and it will be multiplied by the numerator. So in such a case, our numerator is sine x. So when you say cos x times cos x, it is simply cos squared x. Again, there sine x plus sine x times sine x, it is simply sine squared x. And we have our denominator as sine x cos x. And then what is the next thing? You need to know that cos squared x plus sine squared x is equal to 1. So what are we going to do? We're going to replace cos squared x plus sine squared x with 1. So after you replace, that's what you're going to have. It will be 1 over sine x cos x. And then what is the next thing? We are going to split. We're going to split. We're going to split what we have, and the way we're going to split it, it will be like 1 over sine x, and then there we're going to have 1 over cos x. And then you need to know this. You need to know cosec x is equal to 1 over sine x. And then you need to also know that sec x is equal to 1 over cos x. So when you check, 1 over sine x is, you need to know that it is equivalent to cosec x. So we're going to write cosec x. And then we also have 1 over cos x. It is equivalent to sec x. So we're going to write sec x like that. And then when you check in the statement, they started with sec x, and what followed was cosec x. So since this is multiplication, between these two terms there is multiplication, they can be swapped. Sec x can be to the left hand side, and cosec x can also be to the right hand side. There is no harm in doing that. So they can easily be swapped since there is multiplication between them. So when you swap them, it will be sec x cosec x, and that is equivalent to what you are given in the statement, which is sec x cosec x. So this is how you're supposed to prove such identities. So you even say that sec x cosec x, which is on the left hand side, is equivalent to sec x cosec x, which is on the right hand side. So this is how you're supposed to prove. So even say hence proven. So this is how you're supposed to score such marks in an exam room. So I hope you're clear. So I hope you haven't forgotten to subscribe, to like, to share, and to comment. Thank you for watching. See you to another video tutorial.